It's now late March, and we're back with the Fisher. My hand has been fully healed for like 2 months. There's my nice scar where I broke my fifth metacarpal base. But that's a subject for another video. But let's get back to the Fisher. I went on everyone's favorite auction site, eBay, grabbed the manual. This was 3 days ago, I believe. I've already scanned it in on my computer and put it so the schematic is all together. And I've got quite the plans for this thing. I can't remember if I said in the first or second part or not, but I want to completely redo this thing. This is pretty much going to be, when I'm done with it, pretty much the only thing that's going to be the same as the looks. It's going to be completely different on the inside. So, first thing, well, actually, not first. I've already got done. I went through and I got all the capacitors, and I also noted change a couple caps and note which ones are low leakage. As you remember on the tone board, what's on the bottom, I can't flip it, but there was a pair of capacitors that was shorted. Well, the caps that were shorted were CA-12 and CA-11, and these are on the outputs of the one of the op amps that goes right to the amplifier. So these caps are 10 microfarads. I don't know why they're shorted, but I'm going to replace them with 1 microfarads. Because to me, they just look like DC blocking caps. And there's like 15 blocking caps before that op amp, so those being shorted will probably not make any difference. But I'll just replace them with some 1 microfarads. Call it a day. But this thing has a god-awful noise floor. Like, it's quite loud, the hiss and buzz that comes from this thing through your speakers. One thing I'm going to try is I'm going to replace, I want to replace all of the op amps. The op amps it has are, I got them here somewhere. I made an audio karma thread. Everyone can follow along. The op amps this thing has are the JRC 4558DX. Now at first I looked at the NE 5532. However, notice these are max plus and minus 15 volts. And the op amps in this thing run at plus and minus 20. Now the way dual supplies work is plus and minus 15 volts means the chip's running on 30. So if I put this in this circuit, that chip would be running at 40 volts. And I don't know how long it would run on 40 volts if it would at all. It'd probably just explode. So I need to look around for some op amps that can take that kind of voltage, preferably, one that could do like plus and minus 22. But most of your really nice low noise op amps are plus minus 15. But maybe I can modify the power supply in this to send out a lower voltage to those op amps. I'm not sure. But the part that I'm most excited for is after I get done recapping it and doing all the op amps and working on the lights, I'll come back to that. Both of these STK modules, these are both getting replaced. Now, both the modules work. The right one, which has been replaced, it sounds muffled and is weak compared to the original left one. So, back to AK, there is a guy here that built brand new STK 0050s from all new parts. I see he's got the Mauser bomb list. Everything's here. All your insulators, washers, transistors, resistors. 1764. And this will build you one board. Now, the first gen STK packs all shared the same pinout. Matter of fact, when STK packs were still readily available, people would actually use the 0080 to replace the 50. And it worked perfectly. You just lost output power because the 50 runs at, I think it's about 45 volts. Where the 0080 is 55 volts. But there's someone on here, and he tried, see these are the modules when you build them. He has the Fisher CA-800, and what he done was, he wondered, you can see the 0080, if these packs can be used for the 0080. And his short answer, yes they can. He says they work perfectly. In his words, he says, these replacement modules bang the power needles harder than these stock ones do. But he's got a couple of pictures. Like he tried it with another unit. It's a Fisher RS 2004. You see, he replaced both of the 0080s, and he says they work perfectly. So that's what I'm going to be doing with this. The only problem is the replacement packs, they got this aluminum adapter plate, and that adapter plate's wider than an original STK pack. When you see this one, has got these small cutout holes that barely fit the original packs. So I'm going to have to hack away at this back panel if I want those adapter plates to fit in. Hopefully, all I'll have to do is just chop out this one middle piece here. Because see, if I chop away at too much of this back plate, this heatsink's going to have no support, because it screws right into the back of it. Yeah, this is going to be quite a fun project. Oh, turn the light off. Okay. So, coming back to the lights, as I said I would, most of the lights work, but there's a couple that are burnt out. I figure this one for the power needle is burnt out, and this one for the power light is burnt out. Now, people on like eBay's really the only place you can get these kind of bulbs anymore. Like, these are 8 volt, 200, 300 milliamp. I'm not exactly sure, but people on eBay seem to want just ridiculous amounts of money for these little bulbs, especially the especially these smaller ones, which are a nicknamed grain of wheat bulbs. Well, I got a better idea. If we go over to the schematic here, we can see our transformer's got multiple taps, but you see this one tap here, which goes over and feeds all of the lights. The meter lights, the power indicator, and if we follow this and go up, our function indicators. Those are all powered off that one transformer tap, which is 8 volts AC. Now, here's my idea here. If all these lights run off the same single tap, why don't I just disconnect that tap from the board? I'll figure out which, it's one of these windings. Figure out which tap that is. Build a little, I went to Radio Shack and I got one of these PCBs. Well, I need to break it in half. I'm working on a little regulator supply. But I figure, whoops, bust this other half off so I have just this board. Put a bridge rectifier on it. A small filter cap, like 2200 microfarads, and just convert it all to LEDs. I like that idea, and that's probably what I'm going to do, because there's all kinds of space that I could stick that little board. Actually, what's this made out of? That's like a plastic, so I could just, hot snot the glue right down to that board. Then it'll all be LEDs. I think I'll be doing that. So, after a little bit of testing that I completely forgot to record, I checked the rail voltage. This thing is plus and minus 63 volts. It says 55 in the schematic. Why in the hell is this running at over 60? Well, I measured the voltage of the op amps. This one is running at plus and minus 21. And this one's at plus and minus 18. And I forgot about that one, but I don't figure it's any different than one of them. But you see, I halfway took care of this bust in the board. What happens is the board comes out and then it kind of slides out like this. What happened is someone put this in the board, or put the board back in the chassis, in this little slot right here. I've got the broken piece somewhere. But anyway, that broken slot, I cannot English. The slot was bent. So I was able to, well, not deliberately bust that off, but I got a pair of pliers and I was able to bend that back somewhat. See, it's not catching on the thing for the screw anymore. Where is my English right now? But to get that out, I had to remove the board. So my first thought was just unscrew it, take off this bracket which holds the packs against the heatsink, and just slide it up. Well, that wasn't happening, because these modules are freaking glued to the heatsink. I cannot get them off. So what I did was I just, well, I already reattached it, but I unscrewed the heatsink, and then I was able to get the whole thing and slide it up just enough that the end was sticking out. So I was able to slide it up because the packs hit the part of the chassis, and that was just enough to free this. So I went to get my tweezers and grab it, and it just popped off. Now, where did it go? I just had it. But you see, it broke. Although this is an easy fix because it's only this one trace. So I figure I'll just run a jumper wire across it. That's no big deal. I knew that right from the beginning. But it is making progress.
Well, that was simple enough. I just scraped off the solder mask, put on a clipped lead that I saved from probably one of my previous recapping jobs, and there you go. That was... It took longer for my iron to heat up than it did for me to bend that lead, cut it, and then solder it down. I like how neat that looks, though.
So, messing with the op amps in this, I figured since there's no good op amps that can take, the 40-some odd volts, I want to see if there's a way I can modify the circuit to drop the voltage down. So now looking at the schematic here, we see a resistor network, which are those 4 big ones behind the tasty-looking capacitors. Now, at first I thought those resistors would drop the value, but I thought, no, it can't be that way, because if the op amps draw more current, the resistance is going to go up, and the voltage will drop. So you're going to have a constant voltage swing. Well, the voltage is actually set by these two Zener Diodes. And these two Zener Diodes, you can kind of see them. They're right there, in between the resistors. They're 20-volt Zener Diodes, one for the plus and minus rail. So if I change those Zener Diodes, I can change the rail voltage that the op amps run at. And I've already, traced this out. It goes to the op amps and only the op amps. Now, here on the rebuild thread, this guy says, depending on how hot R37 to 40 are, which are those 4 2 watts, you might have to bump them up a little. What voltage are you planning at? I plan on running them in 12 to 14 volts. So what I did here was I turned it on. It's been on for maybe 4 minutes. These resistors are, you can feel the heat coming from them. That's hot. Ow. Ow. Yeah. So those resistors are quite toasty. So I figure I'll probably up them to 3 watts. Same as I'm going to do with the headphone board. This 800 seems like a cheaper version of the 880. Because if you look, we have one common board instead of 3 discrete ones. The caps are 6800 mic instead of 8200. Well, that's about all I can say right now. Oh, and the peak level has no adjustment. You can't adjust the peak level lights. But you can in the 880. Yeah, this seems like it was a cheaper model. Like, it looks the same, but it's definitely not built the same. So, last clip you saw was a couple days ago, as usual. I was discussing swapping out these Zener diodes to change the voltage of the op amps, and it's starting to rain outside. Oh well, I'll leave that open. So, made a little bit more progress. My original plan was to change out all the op amps, but after looking at the schematic a bit, I think I'm only going to change one, and that's this one. Oh, I'm in the middle of a shadow. There we go. This is the op amp that I will hear. This is your tone control. This op amp up here is for the microphone, which I'm never going to use. And this one down here is for the power needles. So if I change that op amp out with one that specs are a little off, these needles are going to be out of alignment. Sure, it's starting to rain, ain't it? And I don't want to put the needles out of alignment, because when they're out of alignment, to readjust them, you got to redo that entire part of the circuit. Jesus Lord, it's starting to rain quite hard. Hang on. Took care of that. Back onto what I was saying. The op amp, so there's another op amp, which is here on the preamp for the phono. I don't even own a turntable, so it can stay. So only this op amp right here is going to be the one getting the swap. I'll buy 4 or 5 op amps, get a socket, and that way I can just swap between them, see which ones I like. But a lot of these cap values are going to get increased. These are your supply rail filtering for the op amps. These are only 470 mic. I'm going to up those to, I'm not entirely sure yet, probably about 1,000 at least. But there's also more filtering for the op amp, which is these two 1 microfarads. Those are going to be increased as well. Back here onto the power amp, these, these 4 caps are all 4.7 mic, and they can be up to around 1,000. But I think I'm just going to put in 220s due to, the space restrictions here. But I also found out this bridge rectifier here is only 6 amps. This thing is going to draw a lot more than 6 amps under full load. These packs are rated for 80 watts into 8 ohms. That's about 3.5 amps. If they're class AB, let's just say worst case scenario, they're about 50% efficient. That means these need 7 amps going into them to get 3.5 out. I don't think they're that inefficient, but, these alone, both of them running at full power, could probably draw 8 or 9 amps. And that's going to wear down the bridge over time. Ooh, and something else I forgot to mention because I was too busy rambling on. These 2 gray resistors, they're each 33 ohms. I'm going to increase those to 100 ohms. That will help to stabilize the rail voltage for the op amps. Cover's off. I cleaned it up a little bit. The front of this is aluminum, and that's a little tricky to clean, but it's better than it was. The plastic cleaned up real good. Just some good old soupy wooter. But here's what the front of one of these looks like. Hang on, this was actually really easy to get off. Just 3 screws on the top, 3 on the bottom, and 1 that holds in the little board for the lights, which is this little guy right here. I found out the IC that this uses is actually the exact same IC I moved it. The Fisher CA-35 uses. It uses the exact same IC because it's got 5 lights as well. Now this board has given me all kinds of trouble because it looks like it runs off of AC voltage somehow, and if all the lights are going to be converted to DC, this board's going to have to be completely reworked. But it'll be interesting. These lights, I really want to replace these with different color ones because they're just normal rectangular LEDs, but the problem is they're only 1 millimeter tall, and 2 millimeter is the standard. I cannot find 1 millimeter tall LEDs anywhere. But that's not what I'm worried about. This thing is so clean. There's just a little bit of dust right around the edge. These needles take nothing to move. Like if you watch them, when my fan comes back around, just that little breeze is enough to make the needles move. Like if I were to blow on these, they'd move around. It's probably not good for them, so I'm only going to do that once. But I cleaned the dirt around all the buttons and the chrome selector switches. You never really notice until you take the faceplate off how far out some of these switches actually stick. Like, look at that. And they go even deeper back into the actual mechanical switch. But I like when you have the volume knob on it. The clicks on the steps on the volume are very noticeable. You hardly feel it when you just turn it. You can hear it. But this is the headphone jack here. It doesn't screw in. What it does, it's got a little metal tab, and that just goes down, gets jammed, because I'm a fucking dumbass, but it just locks down. Oh, fuck, what'd I do? Oh, there we go. Yeah, it just goes down, you stick it in, you're supposed to push it down, but I fucked it up. There you go, like that. Then when you put the cover on, that goes against it. Works, I guess. Messing with the 5 peak level lights. How this is set up is on your input line you have a 22K resistor which goes to ground. This sets how much of the signal goes to ground, and therefore the remaining signal goes into the IC. Now, in the 880 that's a trimmer, but it's not in the 800 because cost-cutting options I'm almost certain of. But to make the chip less sensitive, lower the value of the resistor so more signal goes to ground. Now,
I was originally going to replace this with a 20k ohm trimmer resistor so I could adjust it. But I figure, since I have this massive fucking box of some of the most off-tolerance resistors I've ever seen in my life from China, I dug through them and I grabbed a handful of values to play with. I got some 10Ks, some 1.2s, some 4.7, and, well, I didn't pick out 2 meg, but it's probably in my way. So I took out the factory 22k ohm, which is that little guy, and I stuck in the first one, a 10k. Now, it measured at 9.5, but, oh well, whatever. But it just happens that 9.5k has got this almost exactly where I want it. So give me a second. I have a tone generator here. I'm going to play this. How am I going to do this and record at the same time? So I'm going to turn this on. Make sure that's not shorting against anything. Turn it on. Lit. We're on phonos. I remember before... oh, fuck. I just heard sparks. Damn it. How am I going to do this? So the 5th light by factory is fully lit at 10 watts. I'm going to put a knob on that. Hang on. And so maybe I can rub my hand across that. But you see, if I turn this up to where it indicates about 10 watts, we only have our 2nd light. So if I keep turning this up, we're now past 50 watts. And we're only at our 4th light. Now, when we go full power... 100 watts, that's when we get our final light. That is perfect. That's exactly where I want it. Please don't short. Let me just shut you off. Set it down carefully. Yeah, I need to find a more efficient way to work with this, but I think this board's done. I don't even know if I'm going to replace these caps. I might, because I got a box over there, but... that's done. Well, I figure since I had it out, and I got the sensitivity done, I went ahead and replaced the 2 capacitors. They were 100 microfarad, 10 volt, and 10 microfarad, 10 volt, or 16. 16 for the 10. And I figure since I had those caps on hand, they're both 25 volts, but it doesn't matter. They're still smaller than the originals. Since I had a 10 and a 100 mic on hand, I just went ahead and replaced them. Nigicon VRs, just the standard use caps. When I order, I'm going to get low leakage, low impedance, and audio grades. But this board, I think, is done. So I'm going to pop the front cover back on before I get any more dust on the back of this, because these things are an absolute bitch to get dust off of, because any piece of dust will show. It is now the middle of May, and the CA-800 has made almost no progress at all whatsoever. I've got a big parts list completely built up. I mean, if I had the money, I could just go and order the parts right now for this thing. It's made pretty much no progress. Like, I've used it some just because I wanted to, and that's it. It's done nothing. It's just sat underneath a towel to keep it clean. Although I did get another amplifier. It's dark, can't really see it. But it's a CA-800. This thing will pump out 150 watts per channel all day. Bought it from eBay, 20 bucks, not working, with a shorted output. But that's going to be another video series. Although, this Fisher has changed, but not really for the best. I think I had a Darlington pack fail. Ain't that some shit? This was the original, too. I wanted to keep this, but what happened was I was playing some music. It wasn't really loud. I mean, the meters were maybe just hitting 0.5. It wasn't up at all. And this is for the left channel. I heard a loud pop, and I lost sound. I sat down with the scope and the multimeter. In about 10 minutes, I found out that my speaker output had -3 volts. However, both the positive and negative inputs both had -50 volts on them. So I removed the pack and started digging around the circuit some, and I found that one of the driver transistors, I don't remember which one, hold on a second, I can pull up the manual. So here in the manual, this is your Darlington pack, the left one, these are 2 driver transistors. What happened is this one, Q09, apparently had a base
two collectors short. You see, what I do is, you see the collector goes to the input pin. I should have about 1.5 volts on there, which I had on this side, and on the other channel, I had 1.5 volts. However, I had 50 volts. Negative 50? 50? I don't remember if it was positive or negative. Actually, I feel stupid. But yeah, the collector had here it is, 1.5 CV on it, and I had just about rail voltage. So I figured that transistor has railed, although it's pretty simple to replace. It's just a generic driver transistor. The transistor that failed was a 2SA1047, and it can be replaced with the KSA1381. Now, if I replace that driver, you're going to want to replace the other guy. It's a 2SC2441, and it can be replaced with the KSC3503. Now, these two KS series, they're complementaries, but this 3503 looked real familiar, and I know exactly why. That's the exact same transistor that I used in this Pioneer to replace the infamous 1451, I believe. That transistor is known to go open, which blows the entire amplifier stage, so they've both been replaced with the 3503s. So one thing I thought about doing, but I'm too lazy, that's pull the good driver from the other channel, put it in this one, and then put my Darlington back in it, and see if it works or it blows that out again. But that's, hit my lamp. But I'd be quite salty if this is actually the problem, because I really wanted to keep this. This is the factory original pack. So anyone watching, this is what an original STK 0080 looks like, with the amazing autofocus. Pins are potted. There's a code of something on the back. Most importantly, you note the case and the font. See how it's kind of bold and it's not perfectly sharp? Yeah, that is an original Darlington pack.